You guys know I have 3 kids and they love apples. It's actually their favorite food for all of them. So I have lots of apples in my house and I like to keep a certain size apple around because they're less likely to waste it. So I'm curious because I'm a math teacher and I am curious about a lot of things. I'm curious to see what the distribution of weight of these apples that I currently have in my fridge are. So I want to see if they're really tightly packed together or if their weights are really spread out. So I'm going to weigh all of these apples and then we're going to look at the data and see if we can figure out something from it. So here's the data of all the apples you just saw me weigh, and basically what I'm trying to find out is the interquartile range, because the interquartile range is going to tell me where do 50% of my data lie. You know, because I have little kids at home and I actually kind of like the smaller apples rather than the bigger apples because they waste the bigger apples. They'll take a few bites and then they can't finish them. So it's interesting. I want to see if I have a good weight on these apples or if I have lots of spread out weights. So let's figure this out. So first things first, we need to find our median. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 data points, which means we're not going to have an exact middle, but we're going to have 2 halves. So there's our bottom half, and there's our top half. And so what is our median? Our median is going to be right smack dab in the middle of those 2 halves. Well, we're lucky because one half is, like one side is 6 and the other side is 6. So if I added them together and divided by 2, my median is still going to be 6. So now what I need to do is find my quartile 1 and my quartile 3, which means I split the bottom into halves and I split the top. And I want to find the median of the bottom, or the middle number, which is going to be right here. It's going to be 5.7 because I have 3 numbers below it and 3 numbers above it. And then this is going to be 6.2. So if I drew a box plot for this, you could imagine that it would look something like this. And my interquartile range is going to be this area right here. So 50% of my data is in that center box. And so how big is that? Well, from 5.7 to 6.2 is 0.5. So 50% of my data has a range of 0.5.